So considering future value, it's everything that has to do with saving up for something, saving up for the future, or either retirement or savings, or really when you have an investment that you want to build up for the future. That's when we use the formula for future value. All pensions, funeral policies, endowments, sinking funds, savings, investment policies, they all fall under the future value. And the future value formula that you need to know and understand, the future value is equals to x square bracket 1 plus I, the power of n with its zeros, divided by I, where x is your monthly installments, I is your interest, same as I, then the denominator, and n is really the duration in terms of months. So if we're given a question that will help us get a good idea of what future value is, where Adam decides to deposit 2,000 a year into an account that is earning 10% per annum compounded annually. So we know that he's depositing fixed amount, 2,000, interest 10% per annum. First question, how much will be in the account in 5 years if he starts paying immediately? Keyword immediately or at the beginning of the month. So immediately or at the beginning of the month is virtually the same thing. What you need to know, if it's immediately or at the beginning of the month, you need to know that your future value formula will be multiplied by 1 plus interest to the power of 1. This is very, very, very important for you to remember. If something is made at the beginning of the year, future value, immediately or at the beginning of the month, always multiplied by 1 plus interest. And I'll explain as to why that is crucial. Beginning of the month and end of the month, it's two different occasions. If it's at the beginning of the month, this is the formula we're going to be using. Please make a note of that. So let's go ahead, answer our question. We know that our consistent fixed payments per year are 2,000. We know that our interest is 10% compounded annually, so it will be 10 over 100, which will be 0.1. Since it's annually, it's just going to be divided by 1. And they're asking us how much will be in the account in 5 years, and will be 5. So we can go ahead and calculate what the future value will be. As you said, we're going to be using our magical formula, 2,000, 1 plus 0.1. As you said, it's compounded annually, so it's only going to be divided by 1, and duration is 5 times 1 minus 1. And you notice that I always divide by 1 and multiply by 1 if it's annually. You don't need to, it's just for habit and for really consistency and practice. 0.1 divided by 1. Let's not forget that the payment is made immediately or at the beginning of the month, so it will be 1 plus 0.1, the power of 1, because it's at the beginning of the month. And future value that Adam will realize if we punch everything. So the calculator should get, what I'm getting here is 13,431.22 rands, 13,431.22. This will be the future value that Adam will realize if he deposits his money immediately or at the beginning of the month. So let's go on to the next question, which asks us, what will then happen? How much will be in his account in 5 years if he starts paying at the end of the month? So it's no longer at the beginning of the month, he's changing to the end of the month. So if it's at the end of the month, we only use the standard future value. So we can say end will be that, and the beginning will be that. Or at the immediately, beginning or immediately. So please make a mental note of that. So if it's at end of the month, just use our standard future value formula. Remember, we already established what our consistent fixed monthly installments are. We're going to use future value formula, or we can just extract it here to be smart and save time. 0.1 over 1, 5 years times 1 minus 1, all divided by 0.1 over 1. Then let's punch that into the calculator. And what I'm getting in my calculator is 12,210.20. And if you pay attention, this is at end of the month, and that's the beginning. That's end of month. That's beginning of the month. You can see the beginning of the month is 13,000, end of the month is 12,000. Make a note of that. Third question is an important question. It asks us, why is there a difference in the value of investment when the payment is made at the beginning of the month or immediately and at the end of the month? Why is there a difference when payment is made at the beginning immediately and when it's made at the end of the month? Beginning and the end of the month. Why is there a difference? We can see it's 13,431.22 and 12,210.2. Why is that difference? But an important thing to note is that at the beginning of the month, it earns interest of 1 plus interest for that 1 extra month. So for this investment, it earns more time to compound. So that additional month makes the interest higher. It makes the total investment, in a sense, higher. So what you can say the payment made at the beginning of the month or immediately earns interest for an additional 1 month. So this 1 plus I to the power of n is an additional 1 month. Hence, the investment is higher. So the 13,000 extra, more than 1,000 rands, is because of the 1 month. And it's important that you understand the formula that we derived together. That future value, you multiply it by 1 plus I to the n. This is for when the payment is made immediately. And the standard future value formula, return payments are made at the end of the month.